Hello, welcome. Let's look at another very important metal known as iron. And for us to start this, we are going to be looking at the first transition series. The first transition series consists of elements scandium to zinc. This series of 10D block metals occur in period 4 immediately after potassium and calcium. So the first transition elements are actually the elements that occur in period 4, immediately after potassium and calcium. So they include elements from scandium to zinc. So we're going to be looking at iron because iron is very, very important. You use iron to build so many things in machine parts. So let's look at how we get iron and some of the properties of iron that make it's possible for iron to be used in so many things. Iron is the most important element in the industry. It is the second most abundant element on the earth crust after aluminum, but seldom occurs as a free metal. The common ore is hematite, found in United States, Australia, and USSR. It can also occur as impure iron 3 oxide, magnetite, or magnetic iron ore, which is found in Sweden and in North America. Cedrite or spathic iron ore, iron 2 triisocarbonate 4, found in Great Britain. Iron also occurs as iron pyrite, which is iron the sulfur iron ore, and limonite. Now let's look at the extraction of iron. The most common ore used in the extraction is an impure oxide, hematite. The ore is first roasted in air, during which impurities like carbon, sulfur, and phosphorus are oxidized to other gaseous oxides. Yes, sir. Yeah. Yes. So the ore is first roasted in air, during which impurities like carbon, sulfur, and phosphorus are oxidized to their gaseous oxides and expelled, leaving the silica, which is sand, impurities, which cannot be removed at the initial stage. The roasted hematite is then mixed with coke and limestone and introduced into a blast furnace from the top, while a blast of hot air is introduced into it from the bottom through small pipes known as tonniers. The blast furnace is a tall structure about 30 meters high and 9 meters in diameter at the widest part. It is lined with fine bricks. The reactions taking place in the blast furnace are complex. The temperature ranges from 200 to 2000 degrees Celsius near the tonnier. In the lower part, the white coke is oxidized by the oxygen in the hot air blast to liberate carbon 4 oxide. It is an exothermic reaction, hence a lot of heat is evolved. The carbon 4 oxide produced moves up the furnace and reacts with more coke to form carbon 2 oxide. Near the top of the furnace, the iron ore is reduced to iron at 1000 degrees Celsius by the carbon 2 oxide. The iron formed is impure and is called pig iron or cast iron, which is melted by the hot furnace and moves to the bottom of the furnace. Physical properties of iron. Pure iron is a gray metal with density of 7.8 gram per cm cubed. It melts at 1535 degrees Celsius and boils at 2800 degrees Celsius. It is very malleable and ductile. It is a good conductor of heat and electricity. It is easily magnetized. Chemical properties of iron. Reaction with air. It burns in air to form reddish hydrated iron 3 oxide of variable composition. Reaction with steam. Reaction with steam. When steam is passed over red hot iron filings, tri-iron tetraoxide and hydrogen are produced, and the reaction is reversible. Reaction with non-metals like sulfur, chlorine, carbon, phosphorus, and silicon. It forms iron 3 chloride with chlorine and iron 2 sulfide with sulfur. So one important substance that is made up of iron is steel. So let's look at steel and its uses. About 90% of pig iron got directly from blast furnace is converted into steel. Ordinary steel contains iron and about 0. It is actually iron and not steel. Ordinary steel contains iron and about 0.1 to 1.5% of carbon. The percentage of carbon determines the properties of the steel. The hardness and brittleness increase when the carbon content in the steel increases. Mild steel have a percentage of carbon between 0.1 and 0.4%. These cannot be hardened further, but are used for making motor car bodies, nuts and bolts, and also piping. Hard steels contain about 0.5 to 1.5% of carbon. They are used for making tools. The hard steel can be hardened by heating it to a temperature of 850 degrees centigrade and then plunged into cold water to make it very hard and brittle. This is called quenching process. If the quench scale is heated again to about 250 to 300 degrees Celsius, it loses its brittleness but remains tough. This is known as tempering, and the steel is known as tempered steel. This type of steel can be used for tools and razor blade. Test for iron 2 ions with sodium hydroxide. When a few drops of sodium hydroxide solution are added to an unknown salt solution, a dirty green precipitate which is insoluble in excess sodium hydroxide solution is formed. This indicates the presence of iron 2 ion. If after a time the green precipitate turns reddish brown on exposure to air, this confirms the presence of air because the dirty green iron 2 hydroxide has been oxidized to reddish brown iron 3 hydroxide. Test for iron 3 ion with sodium hydroxide. Add a few drops of sodium hydroxide solution to the unknown salt. The formation of a reddish brown precipitate, which is insoluble in excess sodium hydroxide solution, indicates the presence of iron 3 ions. So that is where we're going to be stopping. In subsequent classes, we are going to be looking at copper. Please, if you like this video, hit the subscribe button. If you have any question, drop it on the comment section. Thanks and God bless you.